Hello, we are Team 11. Our project is about universal AESR or targeted attack. Our team member is Dokyoung, Seunghoon, Junseok, and Chanyang. Our project is advised by Raphael. Here is the brief overview of our project. First, description and problem. An adversarial attack is adding a perturbation on input to fool a victim machine learning model. While the perturbation is usually imperceptible, such an adversarial input can mislead neural network models to output an incorrect result with higher confidence. One way to execute an adversarial attack in real time is to design a single adversarial noise that can be successfully applied to multiple inputs rather than just one. This is called universal attack. Developing a method for generating universal attack is our main problem. We offer some method to generate a universal perturbation which can add all the data points from the same distribution. If we add a universal perturbation on A, B, and C, and then AESR model perceives them as changed ones. And from those, AESR model cannot guess the original sentence. We re-implemented the base paper universal adversarial perturbation for speech recognition systems and tried to add some approaches to make it time invariant. Libre speech is a corpus of approximately 1,000 hours of 16 kHz read English speech. The data is derived from the read audiobooks from the LibreVox project and has been carefully segmented. There are two types of data, clean and other. Clean means the clean speech, and the others means more challenging speech than clean. Among 2,620 data points in test clean split, we used 100 data points to train on universal perturbation, and we used the rest of data evaluate the quality of the perturbation vector. Our baseline is universal adversarial attack. It aims to find a single universal perturbation that can fool most of data points. This perturbation should be small enough to be imperceptible, but it should be fool our target AESR as well. We generate a small perturbation that can fool each data point, and we accumulate and clip these small perturbations while iterating over whole data points. We think generating perturbations succeeds if CER is higher than 0.5 on each data point. If perturbation meets our desired success rate over all training data points, the universal perturbation is prepared. We can just add this to this test data points in inference time. To develop the attack, we concatenate the fixed-sized perturbations to learn according to the length of the voice. Since this can be equally applied to any length of voice, it can be considered as a time universal. Moreover, we hypothesize that this method would have the effect of increasing the training sample, which would increase the performance. We use two metrics CER and WER. Edit distance is the minimum number of single character of word edits required to change the one word into another. WER is the minimum number of word edits. This is the result of our experiment. Here, the train refers to the train portion of the test clean split, and the test refers to the test portion of the test clean split. Table 2 refers to the AESR model performance without applying any attack. From Table 3, we can see the universality of PGD attack. Small SNR means the magnitude of attack is large. On PGD attack, training perturbation vector successfully fools the model on training data set, but fails to do so on the test set. CER, WER drops significantly. However, our universal attack trained perturbation vector successfully fools the model on test data set. This shows the universality of the method. Here's the demo of our work. You can see the adversarial perturbation is added to original speech.
My overwrought nerves yielded at last. My overwrought nerves yielded at last. My overwrought nerves yielded at last.
In conclusion, by developing the universal adversarial attack, we can have better understanding about the vulnerabilities of AESR system. Therefore, our result can provide an opportunity to complement the vulnerabilities of existing system and improve the system's security levels.